although it is true that the majority of the application problems that we do in this particular class are more easily solved using the substitution method, right? Whether they're cost revenue problems or comparisons of two cost problems or even those rectangle problems, they were more easily done with the substitution method. There is this one type of problem that is much easier to solve by elimination, and it's what I kind of call the a little of this and a little of that problem. Okay, so the example that I have here is 6 donuts and 5 cups of coffee. So a little of this and a little of that cost 8.60, and then at the same time, 8 donuts and 4 cups of coffee cost 8.80. So right there in the yellow and the green, you can see the two different equations that I'm going to come up with. Right? It's a little of this and a little of that is 8.60, and a little more of this and a little more of that is 8.80. So find the cost of one donut and the cost of 1 cup of coffee. And usually people find these very easy to write the equations, because what you're really doing is you're just directly translating this into an equation almost, right? Especially if we think of our ax plus by equals c form, right? A little of this and a little of that is something, right? So in this case, rather than using x and y, it might make more sense to use d is the cost of a donut. I spelled donut wrong. And then c is the cost of a coffee. So what's the equations going to be? 6d's added to 5c's are going to cost 8.60. That's the equation 1. And the second equation is going to be 8d's and 4c's cost 8.80. And now you can see, all right, they're both in this ax plus by equals c form. And now I would just solve by elimination. Well, what do I want to eliminate? The d's or the c's? Well, either way, it's going to be, multiplying both equations. So let's say I'm going to eliminate the d's. So I'd say, all right, I have 6 and 8. So the LCM of 6 and 8, right, it's not 48. It's actually 24. Take multiples of 8, 8, 16, 24, and then see what the first one that 6 will also divide evenly into is, and it's 24. So how am I going to turn 6 into 24? Well, I'll multiply this one by 4. And then how am I going to turn 8 into 24? Well, I'll multiply this one by 3, but again, remember, they need to have opposite signs, so one of them has to be multiplied by a negative. Does it matter which one? No, it doesn't matter which one. Let's say I multiply the bottom one by -3. So now what I have to do is just distribute to all three of these pieces in top and bottom, and I'll get the following equations. 24d plus 20c equals 3440, and negative 24d minus 12c equals negative 2640. The idea of multiplying by 4 and -3 was to get these d's to cancel, which they now do. I'll add up the c's. 20c and negative 12c will give me 8c, and I'll add up 3440 and negative 2640, and that's going to leave me with 8. And then if I just divide by 8, I'll get that the coffee, C, is 1. So the cost of a coffee is $1. And now I'll just replace C with 1 in one of the original equations to find my D. So let's use the top one, right? So I'll say 6D plus 5 times 1 equals 860. So 6D plus 5 equals 860. Subtract 5. So 6D is 360. Divide by 6. So a donut costs 0.60, which is 60 cents, right? $0.60 or 60 cents. So the coffee is $1 and the donut is 60 cents. And then you can check on the calculator just to make sure that it works, because especially with this one with the decimals involved and they're bigger numbers. So you probably want to say, okay, so 6 times 0.6 plus 5 times 1. Yes, that's 8.6. And then 8 times 0.6 plus 4 times 1. And yes, that's 8.8. So it does check out. So the coffee is $1, the donut is 60 cents.